Okay, this says, let R be the region bounded by the x-axis, this graph, and this line. It's a vertical line. Read it carefully. I didn't read it carefully the first time I did it, and I messed that up. Okay, so I gotta draw myself an image because that's the way I learn. I'm an image or visual learner. Okay, so there's x equals 4, and this right here is going to be our y equals square root of x, and that's it. Bounded by the x-axis, so that's kind of obvious. There's my x-axis. Okay, so this says find the area of the region R. So we're going to take the integral from 0 to 4. Ooh, 0 to 4. Integral of square root of x dx. But instead of looking at it as a square root of x, I'm going to look at it as x raised to the 1/2 power. Let's go from 0 to 4. We got to do the antiderivative. So we're going to add 1 to the 1/2. That'll be x to the 3 over 2. And then I had to divide by 3 over 2, which would look like this, which is kind of hideous looking. And I'm going to plug in the 4 first and then the 0. But let's get rid of that dividing by a fraction and let's instead multiply by the reciprocal. I don't always think multiply by the reciprocal though, but this one student I used to always tutor, she would always think of it that way. But I like thinking of it as multiplying the bottom and the top by 2, so then this would be eliminated. You multiply the top by 2. It's just another way of looking at it, I suppose. We have 2 times x raised to the 3 over 2 divided by 3. Sorry, you lost your seat. You can't sit here now. Okay. We're going to plug in the 4 first and then 0. Yeah, now you're immortal because now you're in my video and you lost your seat.
It's my extra seat though.
That's your extra seat?
Yeah.
Oh, sorry.
Oh my God.
She stole your extra seat. Okay, so 2. We're going to plug in the 4 first. We have 3 divided by 2 is our exponent, and that's being divided by 3. And we're going to go minus, and we're going to plug in the 0, which is kind of pointless in doing, but I'm going to be thorough here. Because 0 raised to the 3rd power is 0, the square root of 0 is 0, 0 times 2 is 0, and then 0 divided by 3 is 0, so this doesn't matter. Okay, but this one does matter. Okay, you can do the power first, which is a 3, or you can do the root 2 first, whichever one you want. It's kind of fun. I normally do the root first because it makes the number smaller. What is the square root of 4? 2. And then what's 2 raised to the 3rd power? 8. 8 times 2?
16.
So we got 16 over 3, and that is the area of R, of the region R. Okay, letter B says, find the value of h such that the vertical line x equals h, the vertical line x equals h divides the region R into 2 regions of equal area. So we're gonna go like this. Let's do purple. This is gonna be my h. I don't know where this guy is, so I'm just gonna put him right there. But all I know is that this area right here needs to be equal with the other area. Let's do green for our other area. So they need to be equal to each other. How do you find the area under the curve? Well, we just did that. So pretty much, I guess we're trying to find the h that splits this area in half. Now, the way I thought about it is different than the way another student of mine thought about it. Now, let me show you guys how I thought about it first, and I'll show you how the students thought about it. We have B. I thought, all right, so first I'm going to go from 0 to h. So that's from right here to here of square root of x dx. And I want that to equal from h to 4. Square root of x dx. It says, what is h so that these two things equal? You can do it this way, or you can actually go, let's see, from 0 to h of square root of x dx. That should equal 1/2 of what we did already, which is 0 to 4 square root of x dx. Because if it equaled exactly half of what we just found, then we know that we found our h. So actually right now I'm not feeling the way I thought about it. It could work. I don't know. I don't really want to do it right now. I want to do this one because I can simplify this one really fast because I know what this equals. What does that equal? Yeah. All right, so let's rewrite everything up here. Actually, I don't want to rewrite right there. I want to rewrite right here. Okay, so we got 0 to h square root of x dx. And on this side, I have 1/2 times 16 over 3. Yeah, I like that, because now I get to use what I used before. Actually, this would not be a good idea if I was not confident in this answer, but I'm pretty confident in that answer. Let's see, that 2 goes to be a 1, and this becomes an 8, so I have 8 over 3 on that side. And we're trying to figure out what h is right here so that we get 8 over 3. So we do the same thing that we did before. We're going to do the antiderivative of this guy, and since we already did it, let's just copy it. It was 2x raised to 3 over 2 divided by 3. Is that right?
Yeah.
Yeah, it's right there. Okay, and then I'm going to plug in the h first and then the 0. Well, when we plug in the 0, we know it just goes away, so that's kind of pointless. We don't need to plug in the 0. We just plug in the h. We get 2 h 3 divided by 2. Okay, that's the exponent. And we have 8 over 3. Cool, let's multiply both sides by 3. By 3's. Okay, now we have 2h equals, or 2h to the 3 over 2 equals 8. Divide both sides by 2, we get a cute little equation. H to the 3 over 2 equals 4. So how do we get rid of that 3 over 2? We could square both sides first. I mean, there's different ways to do this, but I'm going to do it step by step. Okay, let's square both sides first. Now we have h to the 3rd equals, was that 16? And then we have to go like this and do this fancy like third root thing to both sides, and we get h equals third root of 16. Let's just leave it like that. Let's not even simplify it. Let's just leave it. All right, sounds good to me. Next one says, find the volume of the solid generated when r is revolved about the x-axis. Oh, cool. So now this is turning around our x-axis. Let's see if I can draw one of those discs that it forms. Here's the middle of my circle, and the circle's going around, and then we're going to start seeing dotted because that was behind. Oh, no, that wasn't dotted. Okay, dotted. Oh, that's kind of good. Kind of. There's my radius. Okay, there's my circle. Okay, when it's revolved around the x-axis, and then, let's see, let's draw this thing. Yeah, that looks kind of good. No? Kind of. Okay, it's okay. It's not a perfect one. But anyways, here's a solid. Looks kind of like a bullet. The head of a bullet. It says, find the volume of the solid. Okay, so in order to find the volume of a solid, any solid, what we need to do is we need to come up with an equation that finds the area of every cross-section. My cross-sections in this solid are circles. Whenever you have a volume of revolution, your cross-sections are circles, which is beautiful. It's like you can almost just follow a template. Let's see, what is the area of a circle? The area of a circle is pi r squared. Okay, so what we need is a function for r, because that's what's changing. As I draw new circles, if I draw a circle for the last part right here, that's actually a bigger circle, wouldn't you agree? Yes, you would. That's a bigger circle than the first one that I drew. And so it's the radius that's changing. And how's the radius changing? The radius is changing. The radius's change is defined by this function, square root of x. So, if you have never done this before, I want you to look at this function like it is a distance function. This function defines the distance from the x-axis to the curve. It tells you how long it is. Like, okay, let's say this is an x right here. And you plug in, no, let's not say x. Let's say it's a. Okay, we plug in a to our function. Oops. You would get f of a, which is the same as saying the square root of a. Okay, we plugged in that, and that is our distance. This is our distance. That is the length of the radius. Oh, kind of neat. It's neat when you think about it like that. So instead of writing r, you can write square root of x, which is handy because those are actually the numbers that we're plugging in to find our r's. We're plugging in x values. And so if I say pi square root of x squared, this would find the area of any circle, any cross-section that is a circle in this from 0 to 4. So what we do is we use an integral, because an integral would plug in the 0 and the 4, all the numbers in between 0 and 4 if we do an integral thing with it. Now that pi is a scalar, so I'm going to put him out front. I'm not going to keep him inside there because he's annoying. And then this guy right here, ooh, we can simplify. What is the square root of x squared? It's x. Okay, and the crazy thing happens is you're supposed to have like absolute value bars right there. How come there's supposed to be absolute value bars? Because you're not allowed to plug negative numbers inside of a square root. Are they extremely necessary? Nah, they're not extremely necessary because you can still solve this without using the absolute value bars because we're not plugging in any negative numbers, right? Right. Okay. All right. So let's do the antiderivative of x. We don't have to do the negative x because, again, we're only plugging in positive values. Let's see. We got the antiderivative of x, which is going to be x raised to the second power, and then we're going to divide that. Divide the x by 2, so I multiply it by 1/2. And then we're going to plug in the 0 and the 4 to do our business. All right, first let's plug in the 4. If we plug in the 4, we get 16. All right, let's not do everything in my head. Let's see, 16. Let's see, 4 squared. All right, let's just write it all out. Minus, and then if I plug 0 in, everything's going to multiply to a 0. So I'm just going to write 0. Sorry, I'm going to do that one in my head. 4 squared is 16. Half of 16 is 8, so I have 8x. I'm sorry, 8 pi. Sorry. All right, let's read our D. The vertical line, x equals k, divides the region to R. Oh, we got another thing that's dividing R. Great. Into two regions such that when these two regions are revolved about the x-axis, they generate solids with equal volumes. Find the volume of k. All right, so I'm going to set up the same thing that I did before. I'm going to find the volume from 0 to k. And so then I get, what do I plug? I plug in this square root of x and square it. Actually, you probably could have just plugged in x. And I'm going to set that equal to k to 4. Excuse me. And we have the square root of x squared dx. Oh, I forgot the pi.
Wouldn't it be,
No one else got that.
can it be 1/2 pi? Yeah.
1/2 pi? Why do you want to do 1/2 pi? Oh, because you want to do the 1/2 thing?
Would that work as well?
Oh, yeah, you're probably right. Okay, so let's go pi times 0 to k. You're saying like set it up the other way and solve it that way? Because you guys like that way? Oh yeah, because then we could substitute stuff in there, huh? So we have 1/2 times from 0 to 4 square root of x squared. Oh, okay. Yeah, because we know what this is, right? All right, so what's half of that? What's half of that?
4 pi.
Yeah, so let's go ahead and write it, just because, you know, some people are trying to learn here. We have 4 pi. Okay, so it has to equal 4 pi. And this side, let's see, we have a pi multiplying to 0 to k, and we have an x dx. Let's get rid of those pi's, shall we? Divide both sides by pi. Peace out, pi's. And then we have x to the second power divided by 2, which is the same as 1/2. And we're going to plug in 0 and k. This is supposed to equal 4 somehow. All right, now all I did was I took the antiderivative of that. All right, let's see what we get. We plug in k. We get k squared divided by 2. And I plug in 0, I get nothing. So this equals 4. That means we multiply both sides by 2 to get rid of that. We're back to 8. So we have k squared equals 8. And then k equals the square root of 8.